Hello everyone. So today we are going to talk about the topic of Java memory management. And the analogy which we would be using here would be warehouse management. This would be our analogy for today to understand how Java in NetWeaver Java the memory is allocated and being used. So first of all, take this is a Java host where you have installed your NetWeaver Java NWA Java host. Now, once you assign RAM to it, this is complete RAM. Now, in this RAM, what happens as we have seen in the earlier video of ABAP memory management, it is similar. Few things are getting as few part of this RAM is getting assigned to the OS processes as soon as the OS is getting installed. And on top of that, as soon as you install NetWeaver Java host, the complete area would be used by or the complete RAM would be used by JVM Java Virtual Machine. It would use the complete RAM. Now this JVM, this is my JVM. So this JVM consists of only heap and stack. So what is stack? As soon as the user logs in, the user context which is getting generated for the Java user who is logging in would be taken care in the stack part, and the processes which would be it would be working on, or the objects it would be working on, getting the authorization checks for everything that was being done in the stack area. Once this stack area is done, then only the user is actually assigned heap where it works on the or the process works on the objects, and based on dot objects the memory is assigned from this heap area to the user session. Now instead of work processes we have threads in Java. So for one work process it could be multiple threads working on this complete or for one session it could be multiple threads working on the same process. So that's how the processing works in Java. Now we will understand in depth the memory part, which is this one, heap and stack. So for that we will be taking the example of warehouse management. Let me clear the screen a little. Now consider a warehouse. So this is one warehouse, this is another warehouse, and this is another warehouse. So we have three warehouse, one, two, and three, and all this warehouse belongs to one single company or organization. Okay. Now as soon as few documents, this warehouse is actually processing documents. So suppose uh, there is few documents which needs to be processed. So as soon as this new documents are arrived, this guy takes few documents to warehouse one. Then here my clerk or warehouse manager is there. What it does, it checks the document. So it checks the document on this table which is there with warehouse manager, where it is the working table of this warehouse manager where he is checking the document. So who is my warehouse manager in this case? He is the thread, and the user document which is getting checked here before it could be stored in the warehouse, or before any operations could be taken on that document, this table where it is getting checked is my stack memory, where the user context is happening. Then this document, once checked, it needs to be stored in the warehouse. So it would get stored in warehouse 1. So this warehouse 1 has multiple shelves. So it suppose this document got stored here. Document D got stored here. Similarly, another user came, the document A got stored here. One more user came to store its document. Document B got stored here. Similarly, document C got stored here. F got stored here. G got stored here. So all these are documents which are getting stored. Now, this user, there could be this user or any other user who is coming here and requesting for this document. Hey, I need this D document again. Can you please give me back? So warehouse manager will pick this D document from here and give it back to user. So this area would be vacant. So this area is basically getting vacant. So this is now can be reused by any other user to place its document. So this is now reusable area. Suppose this user went to the warehouse manager and said, hey, my document C, I don't require for 1 month. I require it after 1 month. Then what will happen? Or it will say, the user will say that this document C, I want you to keep it in your warehouse. I would pay the rental for every month, but you have to keep it in warehouse for 1 month. I require it daily in 1 month. So every day I will come, I will take this document from you, and then will just return you back after few hours. So that's how I need this document. And if someday I am not coming, then you have to keep this document stored with you, as I would might be requiring it and some other day. So this is like frequently used document by the user but requires a long time storage. So what warehouse manager will do? Warehouse manager will shift this document C from here to warehouse numbered second. So now my C document got shifted here. Suppose now there is another user. This user went to warehouse manager and said, hey, my requirement is document F. I need it for a 1 year of time to be stored. And this I would be requiring like very often for the rest of the 1 year or rest of the 5 years. So what it would do, it would move it to number 3, third number warehouse. My F document got moved. Now suppose this document which is C here, similarly we have document B also which got moved from here to here. So these places are getting again vacant. This place is vacant, this place is vacant, this place is vacant, which could be reused. Now this B document is there in warehouse number second, which is requested by some user. Now that user is saying that initially he requested for 1 month, but now he's saying, hey, I need the extension to be raised to 1 year. So I would be requiring it daily for the rest of the 1 year. So what my warehouse manager will do? It will remove the storage from here and it would be keeping it in a very long term storage, which would be B over here. So ultimately what is happening? Every time a document which is being used day on day basis but doesn't require a long term storage is placed in warehouse 1 by the warehouse manager, where as soon it is not used, this space is getting vacant and it can be used utilized by someone else or to keep some other document. Now if someone is requesting a document which or an object which is required for some more duration, like for a duration of a month or a 2 month or a 3 month, and requires to be used on a day on day basis, instead of keeping it in regular transactional warehouse which is warehouse 1, my warehouse manager is shifting it to warehouse number 2. And similarly, if further the request from the user is that this document I require for the rest of the 1 year or 5 years but requires to be checked on a day on day basis, then it is being moved to warehouse number 3. So this concept of warehouse management is clear now. Now we will see how this resembles my Java memory management. So in Java, what happens? We have complete area allocated to heap. This is my heap. 1 minute. Now in heap there are three segregations. This is what this is called new new generation. This is called young generation, and this is called permanent generation. Now as soon as a user request any transaction, as soon as a user is logging into my NetWeaver Java system, it is requesting a session and a process, then thread is getting allocated to this user. First the user context is getting checked in the stack memory. After that, whatever objects this user requires is getting moved into new generation. These are now different objects and tables on which it is performing its operation. As soon as it has performed its operation, this area would be allowed to get reused because this space would get clear. Now suppose this user or that process requires few objects, or few object is required by multiple process and needs to be reused again and again, then this would shift from here to young generation. And similarly, if there are any objects which is required by every process, like our metadata objects which is required by all my Java metadata processes, that would be moved to permanent generation because that would be required for a longer duration. So this is how the memory gets allocated in Java system. Now in Java we have something which is called garbage collection. My task of the garbage collection is to make sure this memory, as soon as it is not required, has to be released. So my what my garbage collection does, it does a cleaning job. Now suppose my user has kept this has requested this object here which requires few memory, and now this object has been the utilization of this object is over, and now the process no more requires it. So who is going to clean it? My garbage collection cleans it from the new generation, and then it is allowed to be reused by another process and to keep its own object. Now there are certain objects which are there in young generation which would be required by multiple processes for a some more number of 4 days of duration or on more time of duration. Now once even this is not required after certain duration, then my garbage collection process will check that okay, this is not required anymore, then even it would clean from the young generation. And similarly with permanent generation, so garbage collection basically looks for in the complete heap area what could be clean and what is no more required. That's how the garbage collection work. Like similar to my, suppose there is a cleaning officer here, what his task is to check which all documents is very old and no one is claiming it and it's not required by anyone, and it is trying to remove all those documents from the shelf and move it to a bin. So similarly my garbage collection is doing the cleaning job. And sup- suppose this complete heap is getting allocated, like my warehouse 1, warehouse 2, warehouse 3, all this is getting completely filled. In that case you will start getting oom. Oom is out of memory dumps. When your complete heap gets exhausted, you start getting oom. So what are the how you will find out like why you are getting too many ooms in java? You will have to check from the jvm, java memory management, or from the uh, java virtual machine, jvm. You will have to check. There is a in os you will have to log in as sidadm or root user, and then you will have to run the command jvmmon. JVM will actually give you the complete detail about JVM will invoke the JVM monitor, which will give you all the details about how your Java and heap is getting consumed. And based on that, your it will also give you the details about how much space is getting utilized by young generation, new generation, and permanent generation. And based on that, you will have to understand that whether your garbage collection is working fine, or what are the unused objects which are actually filling this up, and before your garbage collection could clean it, it caused an om. So based on that you will have to take action. If you need to increase your heap, either you can add more ram into it to increase your overall heap size, or you can create a parallel node or a parallel server which would be another jvm with the same sort of heap, so that you can overcome this om concerns or a memory concerns, where your old objects are already there but which are unclaimed and is no more required, but your garbage collection is not able to understand and clean it up, and still causing JOM. This part or error is actually called memory leakage in JVM, because you have object which needs to be cleaned but your garbage collection is not able to understand and is actually allowing the complete heap area to get utilized and given OOM. So you will have to also check for the uh, your memory leakage, because this could be one of the concerns. So after this is like the conceptual video of for Java memory management, and next it would be like hands-on sessions also, which I'm planning to do. So in the hands-on session, I would be including more of kind of commands, visualization on how you check on the OS, how you check on the graphical views, so that you understand what to do in case of this areas. But to understand, like while I would be giving those hands-on session where I would be showing you in the actual system, at that time to understand that like why we are going to those transactions, what does exactly young generation mean, what does permanent generation mean, how does it work, this kind of conceptual clearance or clarity is very much important. That's why it has been explained with a real life analogy, so that it keeps in your mind. And if you want any specific video for any specific topic, do let me know in the comment, and press the bell icon which is there right side on the top, so that if any new video comes you get notified for it. Thank you.